Emerging contaminants in drinking water deeply affect the quality of life. Dr. Socaci and her extensive team of Romanian and Norwegian researchers aim to develop a rapid and green alternative for water remediation. The goal is to develop immobilized nano-structured surfaces. They will exhibit a high efficiency of visible light-driven remediation of aquatic pollutants. Keep watching Research in the Spotlight to learn how their experimental setup can get us closer to better environmental solutions. Dr. Socaci, thank you for having us today.
I'm glad that you came in our laboratories.
Currently, you are implementing a collaborative research project funded under the Norway Grants. How did the idea of this project come about?
It was back in 2018, in summer. Dr. Mateescu, the partner from Bucharest, he was visiting our institute within another collaborative project, a complex project funded by the Romanian government, with my colleague Marcela Roșu. They were developing textiles and leather with antibacterial or self-cleaning properties. So being here, we were having a brainstorming regarding photocatalytic materials on one hand, this is our expertise domain, and deposition methods, which is his expertise domain at IFIN Horeahulu Bay in Bucharest. While having this brainstorming, we got to a nice conclusion. We could deposit our photocatalytic materials on different surfaces by working with him. And then it was this call by EEA Norway Grants, and we asked ourselves, could we enter one of the teams, because the EEA Norway Grants were with different teams. And we were thinking at managing of emerging pollutants in waters. This idea came because we were very long interested in what is happening with the pollutants in waters, like, for example, hormones or drugs, antipyretic drugs, paracetamol, ibuprofen. Our waters, even drinking waters, seems to have a lot of emerging pollutants. We have everything, but we miss the donor partner. Mr. Mateescu, fortunately, he knew Professor Dr. Kai Wang from the University of Southeastern Norway, and he fitted very well the puzzle because he is dealing with titanium nanotubes, photoactive titanium nanotubes for photocatalytic purposes.
Which is the main objective of your project?
The main objective of the project is depositing. So we have surfaces, yet we do not know which surface works better. We have surfaces where we deposit our photoactive materials, and these surfaces then emerged in contaminated water and exposed to sunlight would decompose the pollutants, the emerging pollutants in these waters. This would be the final goal of the project.
Are there any partial results that you would like to share with us so far?
I would first mention the fundamental research that we made really big steps in understanding the mechanistic aspects of these processes, because we have materials that are containing titanium nanotubes, graphene, and metallic or metallic oxides nanoparticles. So it was important to know exactly which is the role of each of these components in the final material. And we managed to understand very well the role of reduced graphene versus nitrogen-doped graphene in the materials, and to establish exactly which is the composition, the mass percentage of this graphene in the final material. Also, that nickel oxide, for example, would have greater photocatalytic ability towards amoxicillin, let's say, one of the antibiotics that is pollutant, emerging pollutant, while gold nanoparticles in the composites have greater ability to degrade beta-estradiol, which is a hormone that is very largely found in drinking water and needs to be removed. Also, we are now somehow identifying the best photocatalytic, the best composite, and it seems that the platinum nanoparticle containing materials would be a very good candidate for, let's say, final composites. Nevertheless, the partner from Bucharest, they were trying different deposition methods, and they delivered us surfaces deposited on aluminium, on inox, on different polymers by 2 different methods. So we are having really good results by having surfaces that are not leaking in the water, which is, let's say, one of the main problems. When we will finish our project objective, we are making really big steps forward towards the total usage of the solar spectrum when we are employing a green methodology like photocatalysis, because photocatalysis is a green methodology to clean waters. Up to now, the photoactive materials are mainly active in the UV spectrum zone, and we could improve this and we could benefit of the entire solar spectrum, which is really good. Another social impact, if we get to the impact on human health, will have crucial importance with beneficial effects on human life. The results of the project can lead to a better water management with great impact on a more adequate use of water, thus influencing the economic development and security. Nevertheless, the project will contribute to the development and qualification of human resources by attracting young people in this research field. We are actually 42% young researchers, PhD students, or obtained their degree less than 5 years ago within this project. And these young researchers are working with highly qualified researchers from the project, and they are involved in writing papers and participation at conferences in order to disseminate the results they are obtaining. The cultural impact of the project, because we are fostering the collaboration with European research institutions, resulting in promoting the Romanian cultural identities and values. This is happening right now. One of my colleagues, she is in a research stage in the donor state. September and October, she's there, and we are planning next year for another colleague to go there 2 or 3 months in order to take advantage of everything within this project.
We are discussing a collaborative project involving a team of researchers with various backgrounds and an international partnership with a prestigious institute in Norway. What does it mean to you and the team you coordinate such a partnership with, and what are the benefits?
This project, we are, let's say, having the opportunity to be only 3 partners, because there are other EEA Norway grants with larger partners. So we are really close to each other and we discuss a lot. It's easier in 3 to have the collaborations. The partner, we and the partner from Norway, they are really specialists in photoactive materials. And as I spoke previously, the Bucharest team, they are specialists in the deposition of these photoactive materials. Nevertheless, the donor partner, University of Southeastern Norway, brings the expertise on titanium nanotubes fabrication techniques. Why is this important? Is because mainly the literature in the field of photoactive materials is discussing about titanium nanoparticles, which are commercially available. The group from Norway, they are able and they have the full knowledge to prepare nanotubes, like straws. You can imagine the nanotubes, titanium nanotubes, like straws where you can drink of. They have a hole inside. These nanotubes, they are fitting better to the to the graphenes we are preparing here. And so the photoactive materials, they have better electronic properties because of the better fitting. Also, the Norway partner is offering fundamental understanding of the graphene-doped titanium nanotubes for degradation of emerging organic pollutants under visible light illumination. They also disseminate the research results through Norwegian micro-nano expertise platform like NorFab. The collaboration is also maximizing outputs. By combining expertise and resources, we are answering bigger and more complex scientific questions, and we are expanding the levels of our research. Nevertheless, the collaborative type of work is maximizing the impact, even in the level of citation of the papers we are writing together. Also, generating outputs that have an impact on policy, practice, industry, or the general public can increase our chances of getting funded. We already applied for Horizon Europe together with a Norway partner. So we also are benefiting, like we expand our network of collaborators in general. And we are also opening for new colleagues, new ideas, new ways of doing research within this project.
Speaking about ideas, can you give us 3 main ideas that people should keep in mind regarding your project?
First of all, I would like the people to know that we can contribute to the development of a greener technology for wastewater treatment. Of course, the technology readiness level, the TRL level that we are proposing is only 4 for now, but if the idea is taken forward to larger TRL levels, then we could really improve the wastewater treatment and to remove emerging pollutants under the sun illumination. That would be the first idea that I would like to have. The second idea is that we can train young researchers in order to have a glimpse, and hopefully they will remain in research. It's really important to have young researchers that would follow and do research further in Romania. Nevertheless, I would like the people to know that this project is increasing visibility of the Romanian teams over research, and I would really, it's nice to know that the people are acknowledging that we do good research in Romania that can really help the society further.
Thank you for watching Research in the Spotlight, a podcast for scientists and passionate science people made under the Norway Grants Research Programme by the Executive Agency for Higher Education, Research, Development and Innovation Funding as program operator. Until the next time, like and share this episode if you think science is a key to a better future.